Good afternoon. My name is Yuval Shapner. I'm the program manager for the Advanced Sensors and Instrumentation program, and I'll be talking to you about this and the subtopic for Neet 2. The Advanced Sensor Instrumentation program vision is to develop advanced sensors and instrumentations to address critical technology gaps for monitoring and controlling advanced reactors and fuel cycle technologies. Our goal is to provide cross-cutting research that contributes to the success of the DOE-NE R&D programs by obtaining needed I&C technologies that support experiments, deliver unique sensors and related technologies for each reactor technology concept and fuel cycle facility, and research that enables the broader mission of the Office of Nuclear Energy by supporting common I&C technology development objectives. Also research that can overcome the current barriers to nuclear energy system deployments. This includes research that resolves technology gaps, enhances functionality, and provides focused demonstration of advanced technologies to provide science-level evidence for acceptance. This program provides a new model of I&C that is more collaborative, coordinated, and designed to support many programs at once. The ASI program is divided in four R&D areas. The advanced sensors to develop a fundamental understanding of sensors performance and to improve physical measurements, accuracy, and reduce uncertainty. The next one is digital monitor and control to provide increases in control system performance and self-calibration capabilities. The next area is nuclear plant communication, and we're looking to research and develop communication technologies needed to support greater data generation and transmission demands while maintaining reliability, resilience, and data security. And the last topic is advanced concepts of operation, and we're looking to develop and test higher integral control system architectures where new human and system interaction is defined. Research in these areas need to support at least two or more of the R&D programs listed on the right. This past fiscal year, we conducted a poll of these programs' I&C priorities, and these four areas are still valid. In fiscal year 2014, we're transitioning to a more fully competitive program. In order to accomplish this without losing some of the initial work that we started in fiscal year 2012, we have decided to request projects in areas that were considered beneficial to the NE R&D programs. These areas are listed as subtopics 1 through 5. Reports describing initial research are provided in this presentation and also will be available on the NEUP website. The subtopic 6 is a new area, and projects will only be awarded if we have additional funding for this. Okay, the first topic is power harvesting technologies for sensor networks. Power harvesting techniques are means to achieve self-powered sensor networks. The goal is to eliminate the need for power and communication cable runs, which are expensive and pose aging problems. We're looking for wireless power harvesting techniques that can be reliably applied in a nuclear power environment. These techniques need to include sensor requirements and simulator to test the concept, design solid-state electronics that minimize power losses, and demonstrate that it can survive in the nuclear environment. The current state-of-the-art of the practice in power harvesting was investigated in various potential energy sources such as vibration, thermoelectric light, and radio frequency were examined for use in the nuclear power plant. Based on this research, it was concluded that thermal energy harvesting is an excellent choice for deployment in a nuclear power plant, and this will be the focus for this research. All this reference here includes that information. The next topic is recalibration methodology for transmitters and instrumentation. Online recalibration or other automated calibration extension methodologies can reduce the maintenance burden during outages. It can also support extended operation intervals and better characterize uncertainties to improve operating and safety margins. The focus of this research is to develop methodologies to extend the calibration interval of transmitters and instruments. These projects should assess methods for improved uncertainty quantification in online monitoring and use the results to develop a robust virtual sensor technology. It should also provide advanced methods for sensor fault detection and signal validation that can be demonstrated in an appropriate test bed or facility. An assessment of the current state-of-the-art and identification of the technical gaps is available in this technical report on the reference. The next area is design for fault tolerance and resilience. Under this topic, we're looking for technologies that can detect and diagnose faults and guide the operator in an appropriate control system response to better recover from upsets. The goal is to avoid operational events that can escalate to become safety challenges or place undue burdens on the operator. Research could include fault diagnostic algorithms to provide early detection and identification of challenges or degradation. Then can be implemented by computers, integrates the operator support system to provide more information to the operator that can minimize fault effects. The goal is to develop technologies that produce a more resilient plant response. A full-scale simulator will be needed for assessing and demonstrating the methods. Two references for work in this area with more details are provided here. The next work scope is embedded instrumentation and controls for extreme environments. Under this topic, we're looking for a bench scale and loop scale demonstration on embedding controls in nuclear components, including methods and metrics to assess performance. Operational efficiency for advanced nuclear plants can be enhanced by high-performance actuators such as pumps, valves, control rod, drive mechanisms. They can withstand extreme environments like high temperature. Current technology limitations constrain design, operation, and length of service. Embedding INC as an integral part of the component design can enable optimal real-time control, improve performance, and condition awareness that support long-term, efficient, cost-effective plant operations. Initial work was focused on demonstrating the embedding concept in a specific motor pump type, and more information on this work is available in this reference. Okay, for the high-temperature fission chamber, we're looking for high-temperature, 800 degrees Celsius, fission chamber prototype for in-core use that can be tested and characterized inside a reactor. This chamber is needed to support high-temperature reactors such as the next-generation nuclear plant and the fluoride salt-cooled high-temperature reactor in measuring reactors' neutral flux. Long-life in-core sensors for high-temperature application are currently not available. Development of high-temperature, high-sensitivity neutron detector allows for a more direct measurement of core conditions, thereby improving operations and safety assurance. A report on fission chamber components technology selection is listed here as a reference, and this report contains a lot of material information that could be used for fission chamber fabrication. Okay, and sorry. The last topic is advanced measurement sensor technology. This is the new topic. It offers a challenge to develop and fabricate a new type of advanced sensor that can support multiple reactors and fuel cycle systems and can provide greater measurement, accuracy, and resolution. Sensing technology limitation creates design challenges arising from the need to rely on distance or indirect measurement of key operational and safety parameters. Advancing sensing technology can remove limitations and allow significant improvements in operation and greater assurance of safety. We're interested in time, space, and or energy spectrum-dependent measurements that will help assess or characterize changes in materials inside the core. New sensors need to be smaller in size and not only survive harsh environments, but also be operational for longer periods of time. Again, please note that any proposals under these areas will be awarded only if we have additional funding. Okay, in summary, I want to stress out that we're looking for advanced I&C technologies that will aid in the reactor and fuel cycle development, improve economics and safety, and demonstration of proposed technologies in a setting that represents the nuclear power industry. Innovative and revolutionary cross-guided technology that can be applied to multiple reactor designs and fuel cycle concepts. Okay, here you have our contact information. My technical lead is Bruce Halbert from the Idaho National Laboratory. He'll be online in case we have technical questions to help me. And for any other additional question, please feel free to contact us. And before I take the questions, I'm going to clarify one question that was posed yesterday regarding limitation of application for the same organization to 3 per work scope. In the Neet 2 area, I just want to note that we have 6 work scopes, so each of these work scopes could have 3 applications from the same organization if applicable. Any other questions? Thank you.
Okay, the first question is, how many awards are expected to be awarded under the Neet Advanced Sensors and Instrumentation?
Based on the funding and the proposed funding, we had about 5 awards, and it could be 6 or more depending if we get additional funding.
The Advanced Concepts of Operations topic is not included. Is this one of the R&D areas that is dependent on availability of additional funding?
That area is not included at this time. We didn't have any. It may be included in later opportunities, but there is a topic related to that area under the light water reactor sustainability. So I think it's I don't know, under the reactors area there is one. Bruce?
RC6.
RC6.
Is there any photonic instrumentation or technology envisioned?
Bruce? I don't know.
That will depend upon proposals. So, again, the general approach for all of this is to discuss the parameter that the sensor applies to, talk about its measurement characteristics, accuracy, time, space, resolution, and other properties, and compare that to the existing state-of-the-art or baseline technologies that it either would replace or would address in a new reactor concept or fuel cycle facility. So we don't envision a particular measurement technology. We are welcoming proposals for different technologies.
You indicated in topic 2.6 that was new and funding on projects in this area is contingent on the budget. Are you still looking for proposals in this area in spite of the uncertainty in budget levels?
Yes, the idea was last year we had additional funding that came available at the end. So if you have any proposals that came out in that area, we can fund it. So we didn't want to leave an area out. And the idea was if we do have additional funding, we will fund. If no, we'll repeat this topic in the next solicitation.
Where do we find the reference ANL/NE-12-57 on your Neet 2.3 slide? The INL one is available, but I could not find the ANL one.
They should be posted. I gave all the references to the NEUP. Should be posted tomorrow with the solicitation. When is? No.
We'll
check
be posting
on
those
that.
out with the presentations,
Yeah.
probably by Tuesday. is my guess of when all that information will be out there.
So they should all be in the same place where the solicitation will be.
Does a proposal have to have a national laboratory partner? For a proposal that does not have a national lab partner, will it affect the review negatively?
This solicitation is open to all participants, laboratories, universities, industry, and it should not have any negative for not having a laboratory participant. It's all on the merit of the proposal.
So we're getting asked some clarification on the limits for Neet, for 3 per institution. If I'm understanding what you said correctly, that means in 2.1 each institution can have 3, 2.2 they can have 3, 2.3 they can have 3, etc.
Yes.
Okay.
Yeah, and ours is a little bit different because we have 6 different work scopes, and we wanted to give everybody the opportunity to apply at least to all of them once. So that'll be 6 instead of 3.
And when it comes to Neet 1 and Neet 2, it's 3 proposals per Neet 1 and 3 proposals per Neet.
Yeah, it's still per work scope because they only have 1 work scope, and I have more.
Next question, are you stating that one organization can commit, oh, we just covered that, so we'll skip that. Regarding Neet 2.6, are there any specific measurement parameters that are preferred, i.e. temperature, fission gas composition, etc.?
I think at this point we're asking for, it's supposed to be innovative, state-of-the-art, so we're looking for their recommendation. But Bruce, do we have any specific? It has to be for cross-cutting, for multiple reactors and fuel cycles.
You know, we don't have anything specifically targeted for 2.6. We have targeted in some of the other areas up to 2.5, some specific technologies that we're looking for. But 2.6 represents an area for the researchers to suggest to us some ideas that they may have about new and novel measurement techniques to enhance measurement accuracy and even to permit finer control or improve safety and efficiency of future systems. So this is an open area. I don't think that we've targeted any specific technologies.
You mentioned that approximately 5 awards will be issued. Does that mean you plan on funding 5 different topic areas, or can a topic area have multiple awards?
The idea will be to fund 1 in each topic area, but it will depend on the result of the proposals.
Which of the funding area, or excuse me, which of the areas are dependent on additional funding availability? Is it just 2.6, or are there additional?
Just 2.6. It's a new area.
Are there any priority for sensor type, i.e. between sensor for temperature, hydrogen pressure, neutron flux, etc.?
For the last area?
It didn't specify. I
Okay.
assume it's across the whole work scope.
I think we're looking for different, it will be up to the proposal, but temperature is usually one of our most interest areas because of the environment. It has to survive the nuclear environment, so anything you can do to get us the measurements we need inside a nuclear plant, that would be good.
Can a proposal fit in both Neet 2.1 and Neet 2.6? I'm assuming this means can be submitted in both work scopes.
No, I think you need to identify which work scope you're submitted to.
Why are some of the reports dated 2012? Were there no reports issued in some topics in FY13?
There were some reports issued in fiscal year 2013, but we're still in the process of reviewing them, so we haven't posted it. The ones in 2012 were the ones that we think are needed to continue this research. They were doing the basic state-of-the-art assessment, and some of them were looking at material selection or other information that will be useful. So if we come up with some of stuff that will be additional help, we'll posting and with the solicitation.
Are proposals that include industrial partners viewed as more beneficial than those with a single proposer?
We always like to encourage participation from multiple organizations, but I guess it will be based on the merit of the proposal.
If a proposal for topic 6 is ranked much higher than proposals in topics 1 through 5, could topic 6 be funded instead of the items in topic 1 through 5?
I think we will need to discuss when we get those and see how that affects. But right now the other ones have a priority because we have invested some funding already in the previous years and we don't want to lose that momentum.